This is quite a cool question. I actually quite appreciate this one. Rewrite it so that it is the difference of squares, meaning, let's take a look at that. What did they give us? X to the fourth minus y to the fourth. Those are perfect squares. So this is the difference of two squares. Okay? What's the square root of x to the fourth? It's x squared. X squared times x squared is x to the fourth. Remember, we have one sign of each. And then what's the square root of y to the fourth? It's y squared, because y squared times y squared is y to the fourth. Okay? Then factor the expression completely. One of these two is the difference of two squares. Can you see it? Yeah, this one, this second one is the difference of two squares, x squared minus y squared. This isn't. That's not difference. That first one does not say minus. And if it doesn't say minus, forget it. It's not going to work. That one, the first one, is going to stay the same. That one's going to stay x squared plus y squared because it is not the difference, not subtracting between them. But this one is. This one is. X squared minus y squared. They're two perfect squares, and there's a difference. It means they're being subtracted between them. So one of them's positive, one of them's negative, and then what's the square root of x squared? X. That goes in each one. What's the square root of y squared? Y. Goes in each one. That is the perfectly factored form of this problem. Fun note, just like I said, this one is not the difference of two perfect squares. It's the sum of two perfect squares, and there's no rule for that. That doesn't factor. So all you have to do is say, leave that one alone because it has to be subtraction between them in order for it to work. That's a good problem to highlight some things, right? That was good. I like that.